Welcome back to Code in Action, the series where we build practical backend projects step by step. In this tutorial, we're going to recreate a simplified version of the StrawPoll API, the popular online service that allows users to create quick polls, share them with others, and collect votes in real time. Our API will include 3 endpoints: a get endpoint for retrieving votes, a post endpoint for creating polls, and another post endpoint for voting in polls. Along the way, we'll implement an in-memory SQL-like database to store our data and a payload validation middleware to ensure that the data of every single HTTP request is clean and predictable. Guys, it's no secret, learning backend development on your own is extremely hard. Before becoming a senior Node.js engineer with now over a decade of experience, I've also failed at it for years, and probably for the same reasons that you're struggling with it right now. So this is why I created the Learn Backend Mastery program, a program designed to remove all the guesswork and to take you from dabbler to job-ready Node.js backend developer in only 12 months. The program is centered around an interactive roadmap of 136 lessons spread across 11 branches like the CLI, Bash, JavaScript, Node, SQL, Express, and more, allowing you to always know what to learn, when to learn it, and in which order without confusion. Each lesson is crafted to teach one specific concept in a beginner-friendly and straight-to-the-point way, and is illustrated with code snippets you'll actually use in real projects. And because only practice makes ready, the Mastery program includes 25 hands-on projects with step-by-step commented solutions you can study, including command line tools, system simulators, games with simple AI, online services, and more that will truly challenge you and help you build a bulletproof problem-solving mindset. So, if you want to get serious with backend development and make real progress fast, check out the Mastery program at learnbackend.dev/get-started. Link in the description below. And without being said, let's build. As always, let's start by creating a new directory for our project named StrawPoll Lite, initialize it using the npm command, and install both the Express package for creating web servers and the Joy package for creating object validation schemas. A poll is a simple survey where users can choose one option from a list of possible choices, and each choice submitted by a user is recorded as a vote. With that in mind, let's create a new file named database.js that exports an object literal as an in-memory database where the table's property will be used to store the polls, choices, and votes as arrays of objects, where each element will be uniquely identified by a positive integer called an index, and the index's property will be used to keep track of the indexes of each element. Now, for those of you who are not familiar with SQL-like databases, a table is a related collection of records or entries where each record is individually identified by a unique property, which is usually an integer called an index. This index is often defined as self-incrementing, which means that every time a new record is added to a table, its index value is incremented by 1. To implement this behavior, each object of the polls, choices, and votes arrays will have an ID property whose value will be derived from its corresponding property in the indexes object and incremented by 1 accordingly. This means that, for example, when adding a new object to the polls table, its ID property will be set to the current value of the polls index, and the value of this index will then be incremented by 1 to reflect this addition. Now that's out of the way, let's quickly break down each of the poll, choice, and vote objects that will be inserted into the database object. The poll object represents the information related to a poll, where ID is the poll's indexed, originating from the poll's property of the indexes object. Title is the poll's title or question. Closing date is the optional poll's timestamp after which participants cannot vote anymore. And result visibility is the poll's voting results visibility, which can either be set to public to always display the votes, public end to only display the votes once closing date is passed, public vote to only display the votes once the user has voted, and private to keep the votes hidden. The choice object represents a single choice related to a poll, where ID is the choice's indexed, originating from the choice's property of the indexes object. Poll ID is the poll's index, and value is the choice's text value. Finally, the vote object represents the vote of a user for a choice related to a poll, where ID is the votes indexed originating from the votes property of the indexes object, poll ID is the poll's index, choice ID is the choice's index, username is the voter's username, and user IP address is the voter's client IP address. Let's now create a new file named server.js, and within it write this minimal Express setup where all the endpoints of the API will be attached to the poll router instance and mounted to the poll root path. Once we've done that, let's declare a first get endpoint responsible for retrieving an existing poll that takes a single route parameter named ID and responds with an HTTP 501 not implemented. Let's declare a second post endpoint responsible for creating a new poll that uses the Express.js middleware to parse and convert the message body of an incoming request into JSON objects, and that also responds with an HTTP 501. Finally, let's declare a third post endpoint responsible for voting for an existing poll that also uses the JSON middleware and also responds with an HTTP 501 for now. To validate and parse the parameters and message body of incoming HTTP requests, we'll use the Joy package to create a list of validation schemas that will later on be used by a custom middleware function that either rejects invalid data or forwards the request to the endpoints controller. So let's create a new file named schemas.js, and within it, let's first import the Joy package and then export an object literal that contains a property named after each endpoint. To each object, let's add a property that indicates where the data to validate comes from, whose name directly originates from the properties of the Express request objects, where, as a reminder, the params property contains the route parameters of the request, the query property contains its query string parameters, and the body property contains its message body. Let's assign to the params property of the getPoll object a Joy object that contains a single property named ID, where ID is a mandatory integer with a minimum value of 1 and a maximum value defined by the built-in maxsafe integer constant that corresponds to the route parameter of the getPoll ID endpoint, and by extension to the ID property of an object in the polls table. Let's then assign to the body property of the createPoll object another Joy object that contains two properties named poll and choices that respectively correspond to the poll's information and its list of choices. Let's define the poll property as a Joy object that contains three properties named title, closing date, and result visibility, where title is a mandatory string of maximum 255 characters that represents the poll's title or question. Closing date is either a Unix timestamp expressed in milliseconds that's mandatory if the value of the result visibility property is set to public end, or that can be null otherwise, and that represents the date and time after which participants cannot vote for the poll anymore. Result visibility is a mandatory string that's either public, public end, public vote, or private, and that represents the poll's votes visibility. Finally, let's define the choices property as a mandatory array of strings of minimum one element of one character that represents the list of available choices of the polls user can vote for. Within the body property of the votePoll object, let's define a new Joy object that corresponds to the expected message body of the post-poll vote endpoint. Within this object, let's define two properties named choiceID and username, where choiceID is a mandatory integer with a minimum value of 1 and a maximum value defined by the built-in maxsafe integer constant, and username is a mandatory string of maximum 50 characters. Now that our validation schemas are defined, let's implement a custom Express validation middleware that will use these schemas to validate the data of incoming requests on the various endpoints of the API, and either reject the incoming request with an HTTP 400 if any of the values doesn't match the format defined by the corresponding schema, or normalize the values and forward the request to the endpoints controller. So let's create a new file named schemavalidator.js. Within it, import the schemas module and declare a factory function that takes as parameters a configuration object and returns an Express middleware, where the schema's property is the name of the schema to use, including getPoll, createPoll, and votePoll, and the source property is the name of the request's object property to check, including params for root parameters, query for query string parameters, and body for message body. Within the middleware function, let's first respond with an HTTP 500 if the specified name or source within the schemas doesn't exist. Let's invoke the validate method of the schema to validate and normalize the values of the request object corresponding to the specified source, and set the convert option to true in order to convert string values passed as route parameters to integers. Finally, let's either respond with an HTTP 400 if the validate method returns an error, or add the normalized values to the request object corresponding to the specified source and forward the request to the endpoint controller. Now within the server module, let's import the schema validation middleware and invoke it on every route with the appropriate configuration object. Within the first endpoint, let's first attempt to retrieve the poll object corresponding to the ID route parameter and respond with an HTTP 404 if the poll doesn't exist. Let's declare a data object that will contain the message body of the response. Let's retrieve the choice and vote objects of a related poll. Check if the user has already voted by checking if the client's IP address exists in the list of votes and save the current Unix timestamp. Let's then iterate on every element of the choice list and include each choice in a data object if the user hasn't voted yet. Let's also include the vote summary in the data object if the poll's result visibility is set to public, if it is set to public end and the current timestamp is greater than the value of the poll's closing date, or if it is set to public vote and the user has already voted. Finally, let's respond to the client with an HTTP 200 containing the data object in a JSON format. Let's now test our endpoint by first adding the following object into the database module, which includes 3 polls, 2 choices for each, and 1 vote for the first poll. Let's start the server and open a second terminal window. Now, when querying the poll with an invalid ID, the endpoint should respond with an HTTP 400. When querying the poll whose ID equals 1, it should respond with an HTTP 200 containing the votes but not the choices, since the user has already voted as recorded by their IP address. When querying the poll whose ID equals 2, it should respond with another HTTP 200 containing the choices but not the votes this time, since the poll's closing date is set to December 31st, 2025 at 11:59 and 59 seconds p.m. When querying the poll whose ID equals 3, it should respond with an HTTP 200 containing the choices but not the votes, since the poll's votes visibility is set to public vote and the user hasn't voted yet. Finally, when querying the poll whose ID equals 4, it should respond with an HTTP 404 not found. Within the second endpoint, let's create a new poll object using the data parsed by the validation middleware and assign it the next ID available from the indexes object while post-incrementing it at the same time. Let's store the object into the polls table. Let's store each choice into the choices table and assign it the next ID available while also post-incrementing it at the same time. And finally, let's respond with an HTTP 200 containing the newly created poll ID. To test this endpoint, let's first reset the object exported by the database module. Let's kill and restart the server and switch to a different terminal window. Now, when creating a poll with a missing list of choices, it should respond with an HTTP 400. When creating a poll with the result visibility set to public end and a closing date set to null, it should respond with another 400. When creating a valid poll, it should respond with an HTTP 200 containing the poll's ID. And finally, when querying the poll using the ID returned by the previous request, it should respond with an HTTP 200 containing the poll's data. Within the third endpoint, let's first retrieve the choice object from the database corresponding to the choice ID property of the request message body and respond with an HTTP 404 if it doesn't exist. Let's then retrieve the poll object from the database corresponding to the ID property of the retrieved choice object and respond with an HTTP 404 if it doesn't exist. Let's check if the closing date property of the poll object is set and respond with an HTTP 403 forbidden if the current timestamp is greater, which means that the poll is closed and user can't vote anymore. Let's check if the client's IP address exists in the poll vote list and respond with another HTTP 403 if it does, which means that the user has already voted. Let's insert a new vote object into the votes table, including the votes index, the polls index, the data from the message body, and the client's IP address. Finally, let's respond with an HTTP 200 containing the ID property of the vote object. Let's kill and restart the server one last time and switch back to a different terminal window. When creating a new poll, it should respond with an HTTP 200 containing the poll's ID. When querying the poll we've just created using the ID returned by the previous query, it should respond with an HTTP 200 containing the poll's data, including the choices but not the votes, since the poll's votes visibility is set to public vote. When voting for a poll with an invalid payload, it should respond with an HTTP 400, and when voting for a poll with a non-existing choice ID, it should respond with an HTTP 404. When voting for a poll with a valid payload and an existing choice ID, it should respond with an HTTP 200 containing the newly created votes ID. When voting again for the same poll, it should respond with an HTTP 403. And finally, when querying a poll again, it should respond with an HTTP 200 containing the poll's data, including the votes but not the choices, since the user has already voted. And here it is for today, guys. If this video clicked for you, don't forget to hit the like and subscribe buttons, as it would really help this channel to grow. As always, if you want to play around with the source code of this project, you can download it directly from the Learn Backend website. And don't forget to check the Mastery program, the Zero to Hired roadmap to become a Node.js backend developer in only 12 months. Links in the description below. Thank you for watching and see you in the next one. Cheers.